Hi guys, my name is Vlada, and in this video we will start with the equation of the circle. Equation of the circle. Equation of the circle is given by next expression: x minus a squared plus y minus b squared is equal to r squared, where a and b are real constants. R is greater than 0 and is real constant. The point AB in the real plane is center of the circle, and R is called radius of the circle. So this is the equation in canonic shape of the circle. Now let's start with our example. Oops, sorry, before that I want to do some substitution here, and that substitution is called polar substitution. Polar substitution. Okay. Let's do something like this. X minus a is equal to r times cosine t, where t is some new variable. X and t are variables, and a and r are constants from here. So we actually substitute this expression to this, and y minus b is equal to r times sin t. Okay, this substitution is called polar substitution, so I will frame that. Range of t is not important. That depends on the example we are doing. So let's do our example number 4. Integral over the curve L of square root of x squared plus y squared times ds, where L is given by next two expressions. Actually, x squared plus y squared is equal to 2 times x, and x is greater than or equal to 1. Okay, I will just get back here to draw a picture of this circle. Okay, this will be our picture. Just to have some geometric view of the thing. Okay, I will choose random center AB somewhere here. Okay, this will be the center of our circle, and radius. Okay, radius will be something like this. Okay, and I will draw this line just to help myself in drawing, and this and this. Okay. And our circle will be this blue line. Okay, this and this and this and finally this. Okay, I don't have tools for drawing a circle, but I'm doing my best. Sorry. This blue line is the circle that has center AB, and this will be the radius. From this point to this point is this length here. From this point to this point is our radius R. Okay, let's get back to our example. We will rearrange this equation in order to obtain something like we have here. So we will move 2 times x on the left side, and we also have the condition that x is greater or equal to 1, and we will add 1 on the left and on the right side to pack, sorry, plus 1 to pack everything to this. Okay, here we have x minus 1 squared plus y squared, and that is equal to 1, with the condition that x is greater or equal to 1. So here is the equation of the canonic shape of the circle, this shape at the beginning of the video, and we can see that a is equal to 1 and b is equal to 0. Actually, y squared is y minus 0 squared, so b is equal to 0. And r squared is equal to 1, so r has to be 1 because r is positive. So the center AB of our circle is the point 1, 0, and radius of the circle is 1. Okay, let's draw a picture. Do I have any room to do that? Here. Our axis, the point, the center, 1, 0, and the radius is 1, so we go to the point 0, 0. We go to the point 2, 0. And down here we go to the point 1 minus 1. and up here we go to the point 1, 1. Sorry, 1, 1. So the circle, I will draw this circle with blue line. It's not so nice, but it will do the job. Something like egg. It's not really a circle, but who cares? Okay. This blue line is the equation of this circle, but we also have this condition. Don't forget. Condition x is greater or equal to 1 is also present. So we need straight line x is equal to 1. Let's draw that line. X is equal to 1. From this we have x is equal to 1, and that is the line that goes to the point 1, 0 and is parallel to y x. So our line x is equal to 1 is actually this line, and we are interested in the points that are on the right side of this light blue line, and that are on the circle, of course. So the curve where we are doing integration is this green curve. This is curve L. Part of the circle x minus 1 squared plus y squared is equal to 1. That is on the right side of this light blue straight line, which has equation x is equal to 1. So this green line is our curve L. Okay, but now we will do polar substitution, okay, to parameterize this curve. So the first step, parametrization. Of L, we do polar substitution x minus 1. So look at here, x minus a is equal to r cos t, a is equal to 1, b is equal to 0, and r is equal to 1. So we have x minus 1 is equal to 1 times cosine t from here. Okay, and y minus 0 is equal to 1 times sin t. B is equal to 0, so y minus 0 is equal to 1 times sin t. Okay, and we get that x is equal to cosine t plus 1 and y is equal to sin t. Okay, it's not over. We have to calculate the range of t. We'll do that with choosing the starting point and the finishing point. We can choose any point to be starting point and any point to be the finishing point. So I will choose this point to be starting point in order to get range of t, starting point. So 1 minus 1 is equal to x. 1 y1, and this point here will be the finishing point, fin point. So x2, y2 will be 1, 1. Okay. And now let's see what we have. y1 is equal to -1 and y2 is equal to 1, x2 is equal to 1, x1 is equal to 1. It's better to solve the range of t with this equation. We will equalize y with y1, so y is equal to sin t, and y1 is equal to -1 from here, -1, and when we equalize y to y2, we get that sin t is equal to y2 is equal to 1. Okay, first let's solve this equation. We get that t is equal to minus pi over 2 plus 2k times p, where k is a whole number, and from here we get that t is equal to pi over 2 plus 2k times pi, where k is a whole number. We can choose k. We can choose any k. I will choose, for example, k to be 1. Why not? Okay, so t will start, if k is equal to 1, t will start from minus pi over 2 plus 2 times pi, and that is equal to 3 pi over 2. And from this t will finish in the point pi over 2 plus 2 pi, and that is equal to 5 pi over 2. You can choose any k you want, but k here and k here must be the same number. You can't choose k here to be 1 and k here to be 0. You can't do that. So t goes from 3 pi over 2 to 5 pi over 2. And I will write that here. 3 pi over 2, from that number to this number, that is the range of t. Okay, and we have done our parameterization. I will frame that with some blue. This is the parameterization of the curve, our first step. Okay, the second step will be to calculate ds, and the third step will be to plug in everything, but I will do that in the next video. But let's just get back to see what we have done. Equation of the circle, polar substitution. We have rearranged this equation to get the equation of the circle. We have this condition also. We have drawn the circle. Plugging in this condition, we get this green line to be curve where we integrate our function. And we did parameterization of the curve L with polar substitution. X minus 1 is equal to cosine t, y is equal to sin t. So this is x and this is y, and the range of t we can calculate from with choosing this point to be starting point and choosing this point to be finishing point. We observe the y coordinates of this point and this point. So this is our starting value for t, and this is our finishing value for t. So t goes from this to this. It can also go from minus pi over 2 to the 3 pi, to the pi over 2 if you choose that k is here equal to 0, and so on. So the next two steps I will do in our next video. So bye bye.